Welcome to Codebug. Welcome to another session of Codebug, and today we'll solve a lead code problem. Problem number 1496, path crossing. It's a easy problem. We'll solve this problem and we'll analyze what's the time complexity and everything about the problem. Okay, but before we get started, make sure you hit the subscribe button and ring the notification bell icon so you don't miss any future coding tutorials and challenges. So let me start with the problem statement. Right. So what is the problem statement? If you read the statement, there is a given string path where the path of I will be north. It can be anything. NSEW, that is north, south, east, west, and you are at the origin 0, 0, and in a you are in a 2D plane and you have to walk through this specified path, and you have to return true or false, and you have to return true in if only if you crosses itself at any point, means you revisit at any point, then you need to return true, else you need to return false, right? If it is the first example, so we have to go to the north, then east, then south. So there is no way we are revisiting any point, so we will return false. If we consider the second example, that is, we go the north, then east, then south, then west, and at here point, if you see, we have again revisited the same point 0, 0. So therefore we have to return true, and then we go to the west side. So we have to return only true or false if we revisit any path, right? So let me take you to the document so we can understand the problem statement side. So problem statement side we are clear, right? So if we revisit any point, then return true, just simple, right? So what I'll do, I'll give you the first example, that is the path, right? And if we go, and we can go north, south, east, west, right? So how we can solve this problem, right? And you are at origin 0, 0, right? And let me, the simple mathematics, right? If you are at any point, uh, okay, let me, that is the north, that is south, that is east, and that is west. Okay, for a better understanding, right? And we are here at this point, that is 0, 0 origin. Let me take is this, right? And suppose it's a 2D blend and we need to go to the north, right? So for north, we need to go 1, 0, right? In the same manner, for east, we have to go 0, 1, x and y axis, just a simple thing. And we have to go west, then in that case, we have to go, x axis will be same, but on y axis we will go -1. And for south, we'll go, for y axis we need to go +1, and for the x axis will be the same, right? That will be sorry, that will be -1, 0, because we are going downside, right, for the x-axis, right? So that is the thing. And what we can do, we can store all the points that we have visited, and we'll just return, if any point is revisiting again, we'll return true. Let me give you the for this example only, right? We'll create a set, and inside we'll store the visited point, right? What are the points we have visited? I'll keep it in an curly braces so it will better to understand. Okay, right. So first the problem is an ESWW. This is the string we are given. This is the path we are given. And this is the set. And initially we are at 0, 0. So we are at 0, 0. So what we'll do, we'll store 0, 0. And we can say, or current point, current x-axis and y-axis. So I'll mark it as x comma y. That will be at 0 comma 0. Right. At first we'll go north. So the north myth will at 0, at 0th index will go, and we know that we need to add this point, right? For north we have 2 plus 1 comma 0. So 0 plus 1 1, and 0 plus 0 is 0, and we are at point after first we are at 1 comma 0. So what I'll do, I'll store into the right after n comma 1, where we have to go east. East is 0 comma 1, so 1 plus 0 plus 0 comma 1, so that will become 1 comma 1, right? So we'll store that point also, 1 comma 1. So I'll mark it as 1 comma 1, right? And then we need to go to the south, and south is minus 1 comma 0, so we have to just add minus 1 comma 0. So now it becomes 0 comma 1. So we'll check if it is there in set or not. If it is not, we'll store, and that is the NES, right? And we'll store 0 comma 1 here. Now what we have to do, if we see, we have to go to the west, and the west is 0 comma minus 1, so we have to plus 0 comma minus 1, so that will become 0 comma 0. That will become 0 comma 0, and we know that we have already visited this point, so there is no sense to store this, and we can just simply return true. As it is revisited, we can just simply return true. There is no need to go beyond that, right? If we have to go beyond that, we can also go to the w again, and we have to again 0 plus minus 1, that will become minus 1 only. So this is a simple thing. At last we are at minus point, and we'll return true as we have revisited 0 comma 0 as revisited, and we'll return true at that point only, right? So this is a simple way to solve this problem. So let me take you to the code editor, and we'll solve this problem. Right, why we are using set? Because we need to store the already visited path, right? So what we'll do, we'll initially at x is equals to 0 and y is equals to 0. We are at origin, 9, and then we'll create a set of pair of st, and pair will store the coordinates. Then what we'll do, we'll iterate over the path. We can string we can see the direction of path, and if direction is equals to north, else if direction is equals to south, there can be 4 direction, right? Else if direction is equals to north south, there can be east, and else there will be west, right? And if it is north, right? Okay, let me copy this thing. Right, if we go to the north, then what we have to do, we have to x for the x-axis, we need to plus equal to 1, and y will be the same. So there is we can do right plus y plus equal to 0, but there is no sense of doing, right? Addition of 0 and same thing will be the same thing. And we'll check if st dot find of what, find of x comma y. If x comma y is already present, it is already there, so we'll just return true. So if we go to the south side, then we'll just have to do x minus equal to 1. If we go to the east side, we have to increase the count of y, and if we go to the west side, we'll just decrease y by minus 1, right? And instead of calling again and again for all of the, what I can do, I can, after moving the point, I can directly say, if we have at any point we are visiting the already visited coordinates, then we'll just simply return true or false. We can return true, and at last, if there is no point which we have revisited, then we'll just simply return false, right? And initially we are at point origin 0 comma 0, so that is there already, so we have to just insert into the our set, and yeah, we can just simply run the code. Okay, it's giving an error. Okay, that is character of direction. Yeah, that's working for this. Let me check for the another one. Right, that's working. Okay, let me talk you to the time complexity. Right, we are iterating for each character once, and for at each point we are checking this is there is in the set there is an empty or not, right? So for the set, because it is an ordered set, the time complexity for searching is big of log n for the best, and we can say the time complexity will be big of n log n, and same for the space complexity. We can say it can be big of, and because we are storing the path also, we can just simply return it out and we'll just submit the code. Okay, it's giving an error. Let me check. Okay. We haven't inserted into the. We have just missed it. We have to insert x comma y also, right? After visiting every point. Then we'll just again resubmit. I think it should work. Yeah, that's working. Thank you everyone. Have a nice day. Please do like and subscribe.